welcome to C Programming Lecture 1. In this introduction lecture, we will look into the basics of computers and programming languages. This diagram shows a schematic of a basic computer architecture. Main unit of any computer system is the central processing unit, in short, CPU. CPU consists of arithmetic and logic unit. Control unit. Primary memory unit is the random access memory, in short, RAM. Computer system has input devices such as computer keyboard, computer mouse. Computer has output devices such as display unit, also known as monitor, printer. Computers usually have secondary memory storage units such as hard disks, which are either made of magnetic disk drives or solid-state semiconductor memory devices. Compact portable USB memory sticks. Magnetic tapes. Optical discs, often known as CDs or Blu-ray. Some idea about the computer architecture will help in learning any programming language. Computer, often referred as hardware, is a device that can perform computations and make logical decisions at speed millions or even billions of times faster than humans can. Software are instructions written to command the computer to perform actions and make decisions, which controls computers. Software systems called operating systems were developed to ease the communications between hardware and software in computers. Machine language. Any computer can directly understand only its own machine language. Machine languages generally consist of strings of numbers ultimately reduced to ones and zeros that instruct computers to perform their most elementary operations one at a time. Machine languages are machine-dependent. Example: machine language program that divides voltage by current and stores the resultant resistance can look like strings of numbers, something like this. Assembly language. English-like abbreviations form the basics of assembly languages. Assemblers translate assembly language programs into machine language. Example: assembly language program that divides voltage by current and stores it in resistance, but more clearly than its machine language equivalent. High-level languages allow programmers to write instructions that look almost like common English and contain globally used mathematical notations. Example: Ohm's law program written in a higher-level language might contain a statement such as R equals V/I. Compiler software translates programs written in higher-level language into machine language. Interpreter software directly execute higher-level language programs without the need for compiling those programs into machine language. Compiled programs execute faster than interpreted programs. Interpreters are popular in program development environments, in which programs are recompiled frequently as new features are added and debugged. Investigations and corrections of errors in a software is called debugging. Once a program is fully developed, a compiled version can then be generated to run more efficiently. Common higher-level languages. Visual Basic is used for writing macros in apps like Microsoft Word. BASIC stands for Beginner's All-Purpose Symbolic Instruction Code. Java is used for developing software that are operating system independent. Python is used in animation software like Blender and development of machine learning and deep learning algorithms. C is known as the development language of the Unix operating system. It is possible to write programs in C that are portable to most computers. C programming language. In 1963, a practical version of ALGOL, algorithmic language, was developed at Cambridge University and the University of London, called Combined Programming Language, in short, CPL. In 1967, a simplified version of CPL, called Basic CPL, in short, BCPL, was constructed by Martin Richards, also at Cambridge University. In 1970, a simplified version of BCPL, simply called B, was constructed by Ken Thompson at Bell Labs for the first Unix system. In 1974, a superset of B, called C, was constructed by Dennis Ritchie, also at Bell Labs. ANSI is the version of the C programming language standardized in 1989, in both the United States through the American National Standards Institute, ANSI, and around the world through the International Standards Organization, ISO. ANSI was updated in 1999. In this lecture series, we will be learning the ANSI. Typical C program development environment. C programs go through 6 phases to be executed. Phase 1 is the creation of the C program or source code, commonly known as programming or coding. This phase is the development of the C program in a standalone text editor or an editor available along with a C compiler. Also, as required, editing of the C program could also be carried out using the editor. C program based on ANSI standards can be developed independent to the operating system. But a C program compiled in a compiler based on a particular operating system will generate an executable file, which will be dependent on that operating system. For example, a C program compiled in Windows operating system will generate an executable file that can only be executed in Windows-based computers. Even though a C source code that can be developed independent to the operating system, the compilers and the executable files are operating system based. Popular Windows compiler is the Microsoft Visual Studio, which is a commercial software. Popular free-to-use Windows-based compiler is the Bloodshed Dev C++ compiler that is available with its own editor to program C or C++ source codes. For this course we will be using this freeware compiler. Portable Dev C++ compiler is also available. Portable version of the compiler can be used directly without any need for installation. It is a good practice to gain experience in using different compilers in different operating systems while learning any computer programming language. Unix operating system computers have text editors like VI and Emacs to create and edit C programs. Mac OS based computers have Xcode app that comes with its own editor and C-lang compiler. C programs are simple text files that can be created and edited in any text editor like TextEdit in Mac computers or Notepad in Windows computers. C program files should end with the .c extension. Most C compilers can compile C++ programs as well, so saving the source code file with their appropriate extension is a must to avoid any conflict. Next phase in the C program development environment is the preprocess. In a C system, a preprocessor program executes automatically before the compiler translation phase begins. The C preprocessor obeys special commands called preprocessor directives, which indicate certain manipulations are to be performed on the program before compilation. These manipulations usually consist of including other files in the file to be compiled and performing various text replacements. Next phase in the C program development environment is the compile. The compiler translates the C program into machine language code, also referred to as object code. Phase 4 in the C program development environment is the link. C programs typically contain references to functions defined elsewhere, such as in the standard libraries or in the private libraries of groups of programmers working on a particular project. The object code produced by the C compiler typically contains holes due to these missing parts. A linker links the object code with the code for the missing functions to produce an executable image with no missing pieces. On a typical Unix system, the command to compile and link a program is called cc. To compile and link a program named welcome.c, type cc welcome.c. If the program compiles and links correctly, a file called a.out is produced. This is the executable image of our welcome.c program. Next phase in the C program development environment is the load. Before a program can be executed, the program must first be placed in memory. This is done by the loader, which takes the executable image from disk and transfers it to memory. Additional components from shared libraries that support the program are also loaded. Final phase in the C program development environment is the execute. Finally, the computer, under the control of its CPU, executes the program one instruction at a time. To load and execute the program on a Unix system, type a.out at the Unix prompt and press enter. In the next lecture we will look into how to create, edit, compile and execute a C program using Bloodshed Dev C++ compiler in a Windows-based computer.